Welcome to your Business Calculus Lesson 1.3. We are going to look at more applications of linear functions. Um, Functions in the real world typically have an independent variable and a dependent variable. For instance, age is an independent variable that helps determine the height of a child. Now, there's other variables that can affect the height, but height of a child is a function of age. And so we consider age the input and height the output, age the independent variable, and height the dependent variable. There are some relationships where you have the freedom to consider either variable as the input and either variable as the output. And that's the case with supply and demand. That means you have to be extremely careful that you read in a particular problem what your input is and what your output is. Okay, so the relationship between supply and demand. There is this loop that happens. Supply and demand are both dictated by price, and supply and demand both affect price. That's why we have the freedom to let either quantity supplied and demand be our independent variable and price is our output, or we can let price be our independent variable and the quantity supplied and the quantity demanded be our output. So here's a little synopsis of this relationship. High prices are associated with lots of supply and less demand for a particular item. Okay, so there's this item. If the prices are going up, more and more people are going to be like, that's too expensive. But the suppliers are going to be like, awesome, we're going to make a lot of money selling this, so they're willing to supply more. All right, well, eventually the demand will get low enough that then things have to go on sale to get rid of the extra supply, and prices will start getting lower and go lower, lower, lower. And so while the prices are going lower, people aren't going to supply as much, but the demand is going to grow. Well, if the demand gets big enough that people go, oh, wait, we need to supply more because the prices are going to go up because these things are getting scarce, then the prices will start rising again. So there is this almost like tug of war going on between the quantities supplied and demanded for different prices. So these opposing forces of supply and demand are always working toward a state of balance where demand equals supply. Okay, when demand equals supply, you've found the perfect price to create a state of equilibrium. Okay, so our first example, we're going to consider some sea glass sunglasses. The demand for sea glass sunglasses in weekly sales is Q equals negative 1/5 P plus 200. Sea glass is prepared to supply Q equals 1/3 P minus 12 per week at the price of P dollars. So P is price. So our input for this particular situation is price, and our output is quantity. Okay, there's quantity demanded and there's quantity supplied. Let's figure out what the domain of the demand function is, and then the supply function, and then we'll find the equilibrium price. One thing you have to remember is you can't have negative quantities and you can't have negative prices. So we know that P has to be at least 0. Okay, so P is going to have to be greater than or equal to 0. Well, we need to make sure the quantity that we're interested in at the moment is greater than or equal to 0 too. So we're starting with demand, so Q has to be greater than 0. Well, domain is determined by the inputs, so let's take the rule for Q, and that's in terms of the input, and said that has to be greater than or equal to 0. So negative 1/5 P plus 200 is greater than or equal to 0. We subtract 200, we get negative 1/5 P is greater than or equal to negative 200. So we need to solve for P. We're going to multiply both sides by the reciprocal of negative 1/5. So we're going to multiply both sides by negative 5. And we get P is less than or equal to 1,000. Notice that I did reverse the inequality sign. That happens anytime you multiply or divide both sides of an inequality by a negative. You don't do it when you multiply or divide both sides by a positive, but when you multiply or divide both sides by a negative, the weight of the inequality shifts, so you have to reverse the sign. Okay, there's a couple of ways you can describe this domain. You can write it as 0 is less than or equal to p less than or equal to 1,000, or you can use set notation and write it as p is an element of the interval 0 to 1,000 inclusive. So we've got square brackets, that means the endpoints are included. If we had open brackets, parentheses, that would mean that the endpoints aren't included or that we have an infinity. Okay, so we want to know the domain of the supply function. So P has to be greater than or equal to 0. We know that. So does Q. So we're going to use the rule that gives us the quantity, but that's in terms of P. And so we're going to have 1/3 P minus 12 is greater than or equal to 0. We add 12 to both sides, multiply by the reciprocal of 1/3, which is 3, and we get P greater than or equal to 36. Notice I did not reverse the inequality sign, and that is because I multiplied by a positive, not a negative. All right, so if we say P has to be at least 36 and P has to be at least 0, the P has to be at least 0 is not necessary, because anything that's 36 or larger is also at least 0. Okay, so all we have to say for our domain is P greater than or equal to 36, or you can say that P is an element of the set 36 inclusive to infinity. So what is the equilibrium price? Okay, equilibrium price is where the two quantities are equal to each other. And so we have negative 1/5 P plus 200, and that's going to equal 1/3 P minus 12. And so we're going to solve this. So we add 12 to both sides. We add 1/5 P to both sides, and we get 212 is equal to 1/3 P plus 1/5 P. We get a common denominator of 15. 5/15 plus 3/15 is 8/15. And to solve for P, we need to multiply by the reciprocal. So we multiply both sides by 15/8, and we get $397.50 equals P. So the equilibrium price for sea glass sunglasses is $397.50. So far, we've seen quantity supplied and quantity demanded as functions of price. We can express price as a function of quantity supplied and as a function of quantity demanded. We will call these equations the price demand and price supply equations. We will let X equal quantity, D of X equal price when X items are demanded, and S of X equal price when X items are supplied. So quantity, demanded or supplied, will be the input, and price will be the output. Suppose Brad Edwards, an economist, has studied the supply and demand for vinyl siding and determined that the price in dollars per square yard, D of X, and the quantity demanded monthly, X, are related by the linear function D of X, remember that's the price, is equal to 60 minus 3/4 X. X is the quantity demanded. While the price S of X and the quantity supplied X are related by, okay, so S of X is the price of X items supplied, and that's equal to 3/4 X, where X is the quantity supplied. So we want to find the price when the demand is 40,000 square yards of vinyl siding. So demand means quantity demanded. We have a quantity right here that is going to be plugged in for X, and we'll see what price goes with that. So 60 minus 3/4 of 40, 3/4 times 40 is 30. 60 minus 30 is 30. So $30 is the price when the quantity demanded is 40,000 square yards. Okay, we want to find the demand at a price of $45. So we're being given a function value and we're being asked for a quantity. We're being asked for an X and we need to use the demand function. So we're using the d of x equation. We know 45 is the price. So 45 equals 60 minus 3/4 x. We subtract 60 from both sides to get negative 15, and that equals negative 3/4 x. We multiply both sides by negative 4/3, and so we get 20 equals x. So that's a quantity. So we look and see what units that quantity is in. So we have 20,000 square yards is the quantity demanded when the price is $45 per square yard. Okay, we want to find the price of when the supply is 80,000 square yards of vinyl siding. Okay, so we're being given a value for X. We want to know the function value for supply. So we want to know S of X when we plug in 80. So S of X is equal to 3/4 times 80. So S of X is equal to 60. So $60 per square yard when the quantity supplied is 80,000 square yard. Find the supply available at a price of $60. Okay, that's a function value, and we're going to find the quantity related to that function value, and we're going to use the supply function. So using the supply function, we have $60 equals 3/4 times x. We're going to multiply both sides by 4/3, and we get 80 equals x. So a quantity of 80,000 square yards is available at a price of $60. Okay, we're going to graph these on the same axes in our cast, and you may have to adjust the window as you go, and we're going to see the intersection of the two lines. Okay, so we'll enter the rule for d of x and f1 of x in our calculator. So enter 60 minus 3/4 x and then press enter. And then if you have to, press tab to get f2 and then put in 3/4 x. Okay, so there's f1, press enter. There's f2, press enter. And we only see f2 of x. Well, if you think about it, that makes sense because it goes through the origin, but f1 of x has a y-intercept of 60. So we need to adjust the window. We need to see not only both functions, we need to see where they intersect. All right. So I tried menu, window, zoom, fit, and it fit both functions on there, but I still can't see where they intersect. I can see, however, that the upper line has a negative slope, so it's going down as we go to the right. So I don't need a higher y value, but I need to make my x value, my x max bigger because the two lines are getting closer as we go to the left. So this time I'm going to manually set the window. The only thing I'm going to change is X max, but I'm going to go to menu, window settings, and I'm going to change X max to 50 and then press enter. Yay, we see where they intersect. So we'll find the intersection. Remember, you're going to analyze and you select intersect. You choose a point to the left, scroll past it, choose a point to the right. And you can see right here, they intersect at 40, 30. Now be really careful because you have to stop and think which one's quantity and which one's price. Well, X is quantity supplied, so our equilibrium quantity is 40,000 square yards. And S of X and D of X are function values. Our Y values are the price, and so $30 per square yard. Okay, guys, go ahead, try what problems you can in the problem set. We will work on this together. Remember, you have to read very carefully to know whether quantity is your input or if it's your output. Okay, so you know how to reach me if you need some extra help. I'm always happy to help. Thank you so much for watching the video, and I hope you have a great day.